Hi, good morning. So in today's class, I'm going to discuss about AC tachometers or AC tacho generators. So what is tachometer means? Tacho means in Latin finding the speeds. Generator means it gives the electrical signals. So using AC tachometer, it is finding out the speed of rotational objects. So it is an important transducer converting, and it converts rotational speeds, like mechanical energy is a rotational speed, and converting into the electrical energy. So conversion of non-electrical energy like rotational speed converting into electrical energy. So this is the one of the important transducer converting rotational speeds like mechanical energy into electrical energy. So here the input is rotational speed to be measured in RPM, revolution per minute. The output voltage is, here in the circuit we are using rectifier, so it gives the DC voltage. So the voltage is directly proportional to the input shaft rotational speed. Okay, so this is the circuit arrangement of AC tachometer. So let's discuss, compare with the DC tachometers. So the main advantage is the inherent demerits associated with the DC tachometer generator due to the provision of commutator and brushes, and eliminates in AC tachometer or AC tacho generator. So here it consisting of like a alternator, a stationary armature, stator, a rotating field system, rotor, owing to the generator of EMF in a stationary coil on a starter. So commutation problem no longer exists as like in DC tachometer. Okay, so here in the AC tachometer, the alternating EMF induced in the stationary coil is rectified, and the output DC voltage is measured with the help of moving coil voltmeter or DC voltmeter. So the ripple content of rectifier voltage is smoothened by a filter circuit, and R and C filter circuit we are using to eliminate the ripple content. Then the output of the DC voltage, the pure DC, is measured at the DC voltmeter. So let's see the circuit diagram of AC tachometer. So the main parts of AC tachometer is here: rectifier, capacitor filter, starter and rotor. Okay, so this is the circuit diagram of AC tachometer. Okay, so now let's see what is the construction details and working principle of this AC tachometer. We'll see. So the rotation shaft attached to the magnetic field, because of the magnet attached to the rotational object, the magnet is also moving, which in turns magnetic field is generated. When every magnetic field strikes the coil, aluminum coil, in this wire, electric signal is generated. So it gives the voltage. It is directly proportional to the speed of the rotational shaft. So the voltage is directly proportional to the speed of the rotational shaft or a machine. So the constructional working. So the cylindrical shape magnet is placed between a conducting coil or armature. The rotation shaft of the speed of the object is attached to the magnet. If the shaft is moving, the magnet is also moving in. So in turns, magnetic field is induced into a coil. The corresponding speed of shaft, it produces the voltage. So the voltage applied to the rectifier bridge circuit. So to get a DC voltage connecting across the moving coil voltmeter. Okay, So the magnitude of voltage is directly proportional to the speed of the rotational shaft in RPM. Okay. So the main applications of these AC tachometer normally are using in automobiles, two-wheelers, speed of the drilling machines. The main advantages of AC tachometer, it's less cost, less maintenance, and gives the accurate value in terms of RPM. The main limitation of this AC tachometer is this: for avoiding the shocks, we are using insulation to the circuit. So to avoid the stray magnetic field effects, all the circuits we are insulated. So that is the only limitation. Okay. So the speed depends on both the amplitude of the voltage and frequency. So any one of them can be used as a measure of speed. In AC tachometer is induced voltage that is considered as a required parameter. Okay. So the magnitude of output voltage is directly proportional to the speed of the rotation shaft in RPM. So this is one of the important transducer to convert rotational speeds into electrical signal. Okay. So circuit details, applications, advantages and limitations we discussed in this lecture. Okay. I hope everything have a better idea about AC tachometers. Thank you.